Today I'm going to be demoing the Agent First Boot customization feature. This feature is particularly useful for edge devices that are deployed in areas without standard like networking setups like DHCP. This is for those deployments where operators would typically need to update manual config files or perhaps have SSH access and or custom scripts and update the devices manually. This is another approach to that. It's a totally optional package that can be installed on agents or edge devices with the flight control agent running as well. It's a Cockpit plugin, so if you're familiar with the Cockpit project, this should be a fairly familiar experience. What we've done is build a very simple, hyper-focused onboarding plugin that a operator would log into the edge devices. They would run through some simple configuration steps with the end intention of ensuring that the flight control agent running on that edge device is actually able to communicate to the flight control service wherever that is running. That's kind of one of the main points of this, right? Is that it may be difficult for setups or for whoever is building the image to know how a deployer or an operator is going to be deploying these things in their data centers or whatever. So the intention is to make it easy for operators, the people actually doing the installation, to get the agent talking to the flight control services, and that's where this whole onboarding thing will end. It's a one-shot thing. It's supposed to be configurable for when an agent or for when a device first boots up. It will launch this plugin. The flight control agent itself will be turned off. There's no network connectivity to the service, so there's no point in it running. And then once everything is configured, it would be re-enabled and start enroll into the services and start its normal operations, join fleets, whatever it's configured to do. And we'll start off by showing off this demo. So for this in particular, we have two agents that are set up. They're both just Raspberry Pis running a custom image of the agent and this onboarding utility. The onboarding utility is meant to have multiple ways to connect / configure. It isn't just a one way of doing things. It currently accepts depending on configuration, you can configure a Wi-Fi access point so that the operator can join a network running that the agent is broadcasting. There's also Ethernet, right? So you can, if your devices just have Ethernet, you can plug that into your laptop or the operator's laptop or whatever and go configure it that way. So in this particular instance, what we've got is the first one of the agents is going to be running a Wi-Fi access point. The second one will be running an Ethernet access point. Both of them will be using Ethernet to communicate they will be connecting over Ethernet to the network itself. So in the Wi-Fi agent's case, the operator is going to be connecting via Wi-Fi, and the Ethernet cable will always be plugged in, and so all we have to do is configure the Ethernet and it'll work. For the second, the Ethernet-based agent, there's only one Ethernet access point there's one Ethernet plug. So in this case, the operator will be plugging that Ethernet into their setup device. In this case, it's just a laptop that I've got, and configuring the agent or configuring onboarding. And then as part of that, and you'll see that, is that there's a point in which you can disconnect and then plug that into the physical network itself and let it continue its configuration that way. So in this case, it's just going to be both, like everybody's going to be configuring their Ethernet. You could configure Wi-Fi if that was the way you wanted to do it. It's really up to you, but in this case, it's just Wi-Fi configuring Ethernet and then Ethernet configuring Ethernet. And in this case, the router that I have is going to be the gateway / running DNS, and my flight control services is running on the specified IP, and it's going to be running the services / the API, and it's also going to be running NTP. These bootc images that I built don't have direct network or direct internet connectivity, and the server itself does. So I'm just using that as a NTP host or server for this, just as a way to demonstrate another feature of it. All right, and with that, we'll get into the actual demo. So in this case, notice at the top that we're just connecting to a basic IP with the 9090 port, which is just standard, and we're going to system onboarding. We'll show this later, but it is configurable, what this base IP is. In this Ethernet case, real quick, do want to point out that you are currently connected to this interface, which is what I mentioned earlier. So we are connected via the Ethernet, and on these Raspberry Pis, they have Ethernet and wireless. It's the two configurable things. And yeah, so it's warning that like if we're going to connect via this, that we have to take this special flow to allow you to physically unplug things and plug them back in. But if we were going to configure the Wi-Fi, which we can just do a basic scan for, and pick a random, whichever SSID that you want. But in this case, we're just going to do the regular flow. We're going to set up a static IP. Apologies for the typing, having to watch me type, but yeah. And just configuring everything required. This should all match everything that I showed in the previous screen. And this is just demonstrating that we have the same IPv6 configuration options if you want, but for this demo, I'm just turning it off. For the network services, so this is the next step, go ahead and add NTP servers, which I mentioned that we have to do. You can add multiple if you want. In this case, we just have the one. Also add optional HTTP proxies if necessary. I'm not going to do it for this one. So here is the enrollment into flight control. So this step in particular allows you to skip it. You can if you want flight control, if you want to enroll into flight control, you can. You would do it here. You would request new enrollment certificates, which is the late binding approach. So like if when building the image you don't bake in the enrollment certificates, you can request ones here. If they're already baked in, then you don't have to take this approach. You can just continue on using the existing credentials their existing certificates. In this case, what we're going to do is request new ones. We're going to use a username and password, which is just very simple. I think it's just admin is the user, which I've just set up something very basic. This is all running on my flight control internal server. We'll just show this real quick. Yeah, so if the TLS certificates that are generated by the flight control services install, if those aren't baked into your image, then we allow optionally specifying the CAs for the server certs so that you can do TLS verification. You can skip TLS verification, you can build them into your image, in which case you can just use the system default. But in this case, we're going to be using the custom one for authentication. In this flow, the auth provider is the same as it's using the same CA cert. We're not using a separate OIDC provider or anything fancy. It's just the PAM issuer that comes standard with the quadlets deployment. So we're just using that for this so that we can get TLS verified. For device labels, so this page in particular is useful for when we enroll into flight control. We allow the enrollment request to contain labels, custom labels, so that devices can be easily identified, including like the alias, so it's easy to read, so that the labels can contain information so that they auto join fleets, whatever you would do, whatever a normal operator would want to do here. We just make it simple to add the labels. In this case, I'm just making the host name and using the host name as the alias, adding a simple location label, and then promoting a system info field to a label as well. So in this case, now we're reviewing things. Again, we're showing that we are configuring the interface that you are attached to, and that this will require background functionality. So then, just typical review page shows basic information, everything that we want to do, connectivity tests for if you want to verify that you can reach some endpoint before attempting enrollments. In this case, it's just going to attempt to enroll into, or it's just going to ensure that we can connect to flight control before connecting to flight control, but it's okay. And let's see. And in this case, we're going to click enroll. It's going to take us to this page, which is going to show some basic information that we've applied various configurations. We've applied labels, 2 default labels, one being the alias, the other being the label that we set up. So it's NTP, and a bunch of other stuff. And then onboarding is going to continue in the background, so this is going to lose connection. The operator at this point would unplug the Ethernet cable and plug it into the system and let that connect. So we'll go real quick through the Wi-Fi demo, which should be very similar. Again, in this case, I've connected to the flight control access point that has been created. It's a different IP address. This is you notice I get this banner that I must log into this network before I can access the internet, which is here. This is where it takes you. We're running a captive portal on it for various devices. Let's see. It's going to be a very similar setup. What we're going to see is, in this case, the Ethernet interface isn't what we're connected to, so we were allowed to configure it. In this case, Wi-Fi is the one that we're allowed to do, and you can't scan while we're in the access point mode. So we're going to set up very similar settings. Here we're just showing that you can configure VLANs if you need to, but the settings for Wi-Fi are going to be effectively the same, so we'll just kind of skip through this. Let's see. I'm going to continue to skip. I just set up the exact same information. The interesting piece here is so in this case we're setting up Wi-Fi to Ethernet tests just to make it easier to see. What else? So in this case, the difference is going to be the enrollment. So we don't have to do things in the background. We can do it up front. It's setting information, it's setting up connection profiles, it's configuring NTP, it's syncing with NTP, testing connectivity, enrolling into flight control, and verifying that we have successfully joined. And so then we click finish, and that ends that. And if we then go look at the web UI, what we see are two devices. Here, the Wi-Fi Ethernet test and the Ethernet test. And we'll click into them real quick. What we see here at the top is those labels that we configured, so it all gets propagated properly. Let's let it keep going. And we're going to approve these. And what we should see is that they become up to date, which they do. And then I guess just one final thing that I wanted to show is some configuration. So most of this is configurable when you deploy. If you know certain things, like you want to launch a wireless access point, then you can go ahead and configure that. In this case, for the Wi-Fi based Raspberry Pi, it was this was the configuration used. It launched an access point based on this IP address that you connect to with the password of onboarding. And you can set all this stuff up so that it just, when it configures, that it sets it up with this information. So it's you want to change the password, you can. If you want if you notice that the onboarding user that we created didn't have a password, you can set a password. It's totally up to you, but the intention of the onboarding password or the onboarding user is that they exist only for the lifetime of this service while it's running, with very limited access. It's like it, and then once it's all done, then we effectively disable the user so that it's no longer useful. But yeah, and then the Ethernet. Just real quick, Ethernet configuration just looks very similar to this, and these are where the IP addresses that I was showing earlier come from. That's it.